Alright, so this is my Advanced Concepts Presentation 2. We're going to be deriving the Michaelis-Menten equation. We've got a couple different steps here. A lot of work that goes into this. Hopefully my little contraption I have holding my phone holds up for me. But we're going to go ahead and get this started. We're going to start out with the first step that we were given on our worksheet. So we have the steady state assumption. So we go ahead with we know that our enzyme plus our substrate give us a forward and a backward arrow to our enzyme substrate, which will get us to enzyme plus our product. Three different reactions going on here. 1, -1, and we'll call this one 2. So we have our forward arrow going the one way, backward arrow going the opposite way. These would actually be switched. The backwards arrow would be this one, and this would be the forward arrow, positive one. So from this equation we can tell that ES, our enzyme substrate forming is equal to enzyme substrate loss. So with the forward and backward arrow you can see that these two are going to be exactly the same. We can write this out to say, like, with the numbers that we put on the equations here, so we could say that rate 1 is equal to the rate of our -1 added to our rate 2. Alright, and then this is where it's going to start to, we're going to swap out some terms here. This is so we can swap out our rate values for our rate constants times their reactants, which the reactants, and then we're just going to plug these in for these values here. So for rate 1, we'd have K1, which is our enzyme plus our substrate, is equal to, just like above, our -1 rate, which is enzyme substrate plus the third rate, K2, which is enzyme substrate. Well, so now that we have that, we can go into, we need to figure out the total enzyme amount, but we know that that is equal to the free enzyme amount plus the enzyme bound to the substrate. So just to put that out, to visualize it, it'll make a little more sense. We have our enzyme total, ET. We know that that's equal to our enzyme plus our enzyme substrate. Now we're just going to, again, swap out some terms of what we've kind of solved before. So we can replace on the left to our rate 1, which is enzyme total minus enzyme substrate times our substrate is equal to enzyme substrate, then our rate -1 plus 2. Now we're going to expand this side over here, the left side. We're going to expand that out and then divide by K1 so that we can get that out of there, and we'll get them into a single expression here. So we have our total enzyme to our substrate minus what we have up there above, the enzyme substrate. Which is equal to enzyme substrate K minus 1 plus K2 over rate 1. So this gets us to our single expression. Since all of our rate constants are constant values throughout, they can be combined to give us our Km value, which is our rate constant. So Km would equal K minus 1 plus K2 over our K1. So we'll move that up so you can see that there. So know that Km is equal to that. So you see that is this equation here would be equal to number is the same as number 2 on our sheet that we're supposed to break down, and then we'll start to move on to the next portion over here. We can use the Km value in our equation, and then we can add ES times S to both sides. So let's draw a line here, starting back here. So we have our enzyme total times the substrate is equal to the enzyme substrate times Km plus enzyme substrate times the substrate. Now we can factor out the ES on the right, make it a little bit cleaner. So enzyme total substrate equals enzyme substrate times Km plus the substrate. Alright, now we're going to divide each side by Km plus S to get rid of that on the one side. So if we're just to divide by Km over the substrate, Km over substrate, that's going to give us the following equation. It's going to switch sides, so this is the right side before. ES enzyme substrate is equal to enzyme total times the substrate over what we just divided by, so Km plus the substrate. Alright, so we know that VO is equal to the rate of formation of our product. So VO, which is the rate of our product. And then we also know that that is equal to K2ES. Rate 2 enzyme substrate. Now we can plug this value in back into our previous equation. Get a full fresh piece of paper here. So rate 2 enzyme substrate so our enzyme total we know that with the equation for this one, our VO is equal to our Vmax, which then you could say that your enzyme total is equal to your enzyme substrate, since all of our enzyme is covered by substrate. So then we can just kind of mix and match these two values here and say that our Vmax is equal to K2 enzyme total, which that is number 3 on our worksheet there. We know that to be true because VO is equal to Vmax, and we already found that Vmax was equal to K2ET, enzyme total. So now, to get to our final equation, we'll substitute in some of our known terms. So we'll sub in K2E enzyme substrate for a VO, and then we'll sub in our enzyme total for Vmax to get to our final Michaelis-Menten equation. So VO to Vmax substrate for our Km value plus the substrate, which is number 1 on our equation. Sorry, you couldn't see that. So number 1, number 3, number 2, and then back in here was number 4 from our original equation. Enzyme total is equal to enzyme plus enzyme substrate. So it's pretty confusing. It's a lot of steps, and I've had to read over this and watch many videos just to kind of grasp the concept of working through these with the different reactions, rates, and your enzymes and your substrates. But all of that can get you to the main equation of our topic this week, which is the Michaelis-Menten equation. So hopefully that made sense to you. It took a while for it to make sense to me, but thank you for watching, and have a good day.